Hello everyone, in this video we'll be learning about file handling in C++. So we remember that our first import #include IO stream actually stands for input and output streams. So we'll be working on the input and output streams coming from the console. So in order to work with files, the concept is similar, but what we use is file streams, and for that we use the library called fstream, which provides classes called ofstream, ifstream, or fstream. So as you can guess, ofstream will actually work for output file stream, ifstream is input file stream, and fstream in general will work for both. So how we work with files is very similar to how we work with reading and writing input to and from our console. So here what I've done is I've created two classes, two objects of different classes, ofstream fout and ifstream fin. The reason why I've written fout and fin is because they resemble very closely in their behavior to cout and cin. Then in order to open a file to actually read or write onto it, we use the open function. So in this case, fin open, what it does is it opens this file and makes a file pointer over here in fin to point to that file, and then we can begin with our operations. So while opening, we can also have different modes. In our case, for now, the mode is read, but while writing, we can give it to write, we can give it to append, etc. So we'll see that when we are actually opening a file to write onto it. So here what I'm doing is I'm with the relative path of the file name, or the exact part of the file name. I provide that file name, and if such a file is present, it opens it, and then fin we can use it very much similar to how we would use cin when we are trying to read our input from our console. See here what I've done is I've taken an str, and what I'm doing is fin the extraction operator str. So this is very similar to C in str, wherein what we do is whatever is present in the console buffer, the input buffer, we take that and we store it to str. Now the extraction operator actually cuts at white spaces, so we'll again expect the same behavior from fin when using the extraction operator, such that it will only read the characters up to the first white space it encounters. Then what I'm doing is I'm printing it onto my console, and I repeat that sometimes so that we can see what is actually going on. So we see that the first one, what it does, it reads #include. The second one in which I've written fin in extraction operator str, it reads iostream and using. Then what I've done is I've used the getLine function, again very similar to how exactly similar to how we use for cin. What it does again is reads a continuous line of characters until it encounters a new line character and stores that to str, and which in my case, so we know that after using there'll be a white space. So from that white space till it encounters a new line character, it reads and it prints it out to the console. It shows to str and prints it out to the console. Now, what happens when we want to read specifically certain characters, or we want to move around in the file? So what fin maintains is called a file pointer. Now what the file pointer is basically a pointer pointing to which character from the character from which it should read next. For example, after reading str, it came to #include and the space after that. So next time when we call fin extraction operator str, the fin will actually work from that particular pointer. So our pointer is over here. Let's actually print the file we are actually working on right now, datatypes.cpp. So what will happen is after my pointer is pointing over here, when I again call an finstr, it'll start reading again from here, and then its location will be updated to here. and further operations will cause it to move along in the file. So it will keep on moving as long as we are reading our data, and whenever we stop reading, this is where it will come and stick until the next time we actually operate on it. So C++ also provides us with the ability to move this pointer around freely, so that upon depending upon our convenience or our need, we move it to such a place such that we can read whatever the values we want from it. So that is done using a helpful little function called seekg. So what this takes in as input is the offset. So from which offset to which offset you want to move the pointer to, and from where in the document. So iOS CUR means from the current place, move it to whatever offset I give it to. From the beginning of the file, if I want, I use iOS BEG, and if I want to read from the end of file, I use iOS END. So now let's actually see this in action. We see that it reads TURN, which is probably this TURN from our return function. So it comes to the 10th character from the end, and from there it reads whatever it can till the first white space it encounters. Now what I can also do is I can move it 10 characters from the beginning of the file, and then we get IO stream. And similarly, 10 characters from the current, I'll move it ahead by 10, and from there I'll start reading. So we see that it goes to EMO, which let's try and figure out what it is from. It will be the EMO from our demo. So that's how you open a file, you read stuff from it, and we also learned how to actually move around our file pointer according to our convenience. Now, one more handy thing which you will probably be using is, instead of continually writing, okay, read a line, read a line, read a line again, what we can do is we can simply use this function, or we can make use of the file pointer to keep on reading lines until we reach the end of the file. So what this function does is fn eof tells if we are at the end of file or not, and if we are not at the end of file, keep on reading a line. So this function effectively reads an entire file and points it and prints it out to our console. So before that, what I'll do is I'll move my file pointer back to my beginning of the file, and then I'll read it all. So we see that after writing all of this struct, what we okay, let's actually do a manipulator endl over here, so that our file which we're reading and writing onto our reading from the file and writing onto our console is actually printed in a new line, starting from a new line. Right. So here we see that whatever operations we did before, they end over here. And from here on, we are able to print our entire file onto the console directly from our program. So this has been about how you read a file. And after you've done reading with your file and done with all the operations you want to do in it, since we opened a file, we should close it as well. And you do that using the close operation. Now, let's try and actually create a file and write onto a file. So why I tell create a file is that in our example, so here lste star, we see that we actually have a text.txt. So what I'm going to do is I'm going to remove text.txt. So we see that there are no more text.txts over here. So what I want to do now is I want to create, or actually write onto a file, my sentence. This is what I'm writing onto my file. I want to write this onto my file. So again, since I used fn to read from our our file, I want to write onto a file, so I'm using fout. So fout.open text.txt. Now what this does, it'll open it in write mode, meaning that each time it will rewrite from the starting. So this is basically overriding the file again and again, overwriting onto it, so that whichever changes or whichever text was saved onto it before will get overwritten. And how you actually come, or how you actually fix that, is using iOS uh, append. So app. Right. So what I do now is I open my file, and similar to how we use cout to write to our console, which is cout writing to my console. Very similar to that, what I do is I write fout. This is what I'm writing to my file, and then endl, meaning I'll end my uh, I'll end my line of my file with a new line character. So I compile the program, I run it. Actually, let's first see if the file exists or not. So te star. So we see that no file such exists yet. I run the program, then I check again, and we see that text.txt is actually there, and we see that this is what is written onto our file. Now what I'll do is I'll run this program again, and what should happen effectively is, since it's in append mode, it'll open the file, and after the end of that file, and from there it'll start writing again. So if I run the program again, and I do another cat of my text.txt, we see that it's there twice. So if I do it another time, it'll be there thrice, etc. Now what happens if I'm actually not giving it, or reopening it in write mode actually? So let's compile a program. Oops. So then we do a cat te xt.txt. We see that there is another file. Now I again run it. We see that the line still exists. There's only one line. So this is what we mean. Now we know that text.txt has, this is what I'm writing to my file as its content. What I'll do is, yay, welcome to DevTown. So I compiled my program. Let's actually check the content of the file before and after we call our program. So we see that this is our old content. I do /files, then I do a cat again, and we see that the original content is actually overridden. So this is what happens when you write it in write mode versus what happens when you write it in append mode. So in this video, we learned about how we can actually open files, read content from it, write content to it, and read content specifically from certain points of our file as well. Thank you.